many of you have heard of a function before? Several of you have. Do you know what it is by definition?
No. Not by definition. Not as a number. I feel like it's function. Okay.
A function is a relationship. You know, we talk about when we're graphing lines and graphing other things that we talk about input and output? Yes or no?
Sure.
What is input?
Yeah. What you put in.
Give it to me in terms of a variable.
You control it.
X is usually my input, right? And my output, or what I get back, is my y, right? Well, a function is a relationship, and we can look at it in a table, we can look at it graphically, we can look at it algebraically from an equation, but a function is defined as a relationship that has one and only one. And if I say one and only one, that means that's very, very important, right? Right?
Right.
Say it again, Darian. Output for what? For each input. So I can't get two different y's for the same x value. Does that make sense to you?
What did you say?
If I can only have one and only one output for each input, that means every x has its own y. Your y doesn't, if I have the value of 2 for x, if I'm talking about x and y, I can't have y be 5 when x is 2 and have it be 7. Because each input can only have one output. Does that make sense?
2 is going to have a different number than your 4 is going to have a different number than 1,000.
Yes, right. But
if like 2 is like,
so these numbers could repeat, but my x's could not, basically, okay? So it's easier, I think, to understand it graphically. So what I mean by that is, let me draw you an example of a function and not a function. Let's look at a parabola. Yeah, sure. All right, so here is a parabola. Let's do a sideways parabola. Which one do you think is a function?
The one on the left. The one on the left.
Why?
They're both a function, aren't they?
No, one is and one is not.
because they can't go through each other.
What can't repeat? You can't have the same what?
Can't go through the y-axis.
You can't have the same y for one x. So if you think about this, let me put it on like a coordinate plane here. If this is x and this is y, okay? This value of x right here, it has exactly one y value that corresponds to it, yes?
Yes.
This x value, exactly 1. Is there ever a place where there's not exactly 1? No. Okay? But if you look at this second graph, okay, if I put my axis on here, is there ever a point when you'll have two y values for one x? Yes. Look, if I come right here, it has 1, 2. If I come here, it has 1, 2. It only has to happen once for it not to be a function, okay? So not a function. This sometimes, well, actually all the time, we call this a vertical line test. And it's what you're doing. You're just not actually putting a vertical line on here, but I'll show you. Vertical line test. And what it says is if you take a vertical line or something like your pencil, okay, and you come across this graph with that pencil, if the vertical line ever touches twice, that means it fails the vertical line test and it's not a function. In other words, there's more than one y for a particular x. Does that make sense? Yes, no, maybe so. Let me give you another example and see if you can. Sorry, I'll go back. What if I have something that looks like this?
Next one, I'll follow
Is this what our homework's gonna be on?
Not quite, I'm introducing. Shh, shh, shh. All right, guys, pay attention. Which one is not a function and why?
Yes.
Yes.
The 2.
The one on the right, the one that looks like a backwards S. Why is that, or 2? Why is that not a function? If you take a vertical line, it hits more than once. Do we all see why? A vertical line, anywhere on that graph that hits more than once, it fails. It's not a function, yes? Okay. Take out the sheet that I just handed you. Looks like this. All right, let's talk about it for just a second because we're going to apply this. This is going to be what your homework is going to look like. All right. I've got a scenario here because we're kind of setting up getting into some word problems and some application type things with linear equations. But before we do, we're going to talk about function notation. All right, so you can read the little paragraph there. 2 area distributors, Barking Lot Grooming and Hunter's Tidy Paws, sell and deliver the same kind of shampoo for dogs and cats to area veterinary clinics. The functions, there's that word functions we talked about, right? The functions used by each distributor to calculate the cost to the clinics are given below. So you got 2 equations. Do we all see that? You didn't have to form them yourself. I'm giving them to you.
Thank you.
For now. And then it says to evaluate the cost for 9 bottles, 15 bottles, and 25 bottles of shampoo for each distributor. Okay? So I want you to think about this for just a second. Let's look at Barking Lot Groom first. Okay? If I want to know how much it cost for 9 bottles, what do I do?
Plug in.
Plug in 9, 15, 25.
Plug in what for what?
If plug it in for X.
Plug it in for X, right? So for 9 bottles, I would let X equal 9, and I'd plug in that formula, yes?
45 plus 3, 48.
5 times 9 plus 3. Are you with me?
Hold on.
Okay.
So we gotta plug 15, 9, and 25 in the X.
Correct. Correct. We're not going to do all 3. We're just going to do 9 for both of them so I can show you so we can get to the function notation. Okay? Everybody saying 48. Everybody is right because 45 plus 3 is 48. Yes? So it's $48, right, for 9 bottles of shampoo. Do we agree with that?
Yeah.
You do Hunter's Tidy Paws. Tell me how much it cost for 9 bottles at Hunter's Tidy Paws. Wow. That was quick. Does everybody else? Let everybody else have a chance to do it.
I mean 9 times 2. Right?
48.
Say that again, Deandra.
I do this 9 times 2. 2 times 9.
3 times 9 plus 21.
Yeah, 48.
Oh, look. Is it the same thing? Interesting. All right, do we have any problems plugging in that way? Everybody understands, yes? We can do the other ones if we need to. Are we good? Okay. Then let's move on down. Where am I? And talk about function notation a minute. So we use what we call function notation when we need to, one, let everybody know it's a function, but two, it kind of helps us keep track of things. And I'm sure you've seen before something that looks like this, f of x. Have y'all seen that before? Yeah. All right, so make your note if you haven't. This is red, f of x, okay? The f could be any other variable. It doesn't have to be an f. As you can see down here, we've got b of x and h of x. Does that make sense to everybody? Mm-hmm. So what have you basically done? What's been replaced?
The F?
No, what's been replaced like from the original? Because these equations are the same, but what's different? The y, right? So we have taken the y off and replaced it with b of x. Okay, so that's saying that b is a function of x. This is my input. The whole thing is my output. Same thing here with h of x. F of x, h of x, and g of x are our most common function notations, but any of them can be used. All right, so input again. Does that make sense to everybody? Are you sure?
So X is the input, the whole thing is the output.
Correct, correct. So now, if I want to evaluate for a particular value, let's go with 10 bottles. Instead of just saying x equals 10, I can say
H?
find
Well,
b of 10. Does everybody understand what that's doing? If I say find b of 10, I'm telling you find the output if you plug in what, Amaya? 10, okay? In parentheses tells you what to plug in, basically, is what I'm telling you, okay? So you tell me what is, sorry.
so that'd be 3 times 10 plus 21.
Let me get it back. There we go. You weren't done? Are y'all done now?
So that'd be 5 times 10 plus 3. I was going to see.
Y'all got that? Can I erase it? Okay. Now let's go down and all right. Now I want you to find b of 10 and h of 10. So do that on your own real quick and see what happens.
53 and 50.
You in your sheet?
But I got everything down.
All right, so Darion said 53. I got the same thing. Did you all get the same thing for B of 10? And H of 10, excuse me, 30 plus 21, which is, did we all get the same thing? Yes. Do you see? It's just a different way of writing it. It's nothing too complicated, I hope. It's easy? I hope so. Okay. Are you confused? That's okay. What's wrong? Yes, that's all we're doing. We're plugging into, when you define a function, that's the equation, and then you can say, okay, if h of x is 3x plus 21, find h of 2. Well, you would just plug a 2 in for the x. Whatever's in parentheses is what you're replacing that variable with. All right, let's flip it over to the back. All right, so I got a little recap on here for you to remember. Okay. It doesn't matter. The only thing that's changing is the function notation. Okay? Does that make sense to everybody? The y is being replaced by f of x or g of x or h of x or whatever variable that we're using. Thank you. Make sense?
Are you going to take these numbers that got F, like if it's F negative 2, replace them with X?
Yes.
Hope the X is on the side.
Yes, whatever x's are in the equation, DeAndre. So look at the chart down here on the bottom. Okay? I'm giving you an equation.
Right.
And we're going to find all of these values. So basically, we've got our x here.
Right.
We're plugging in and we're going to tell what it equals.
Right.
Okay? So let's do this row together.
Right.
F of negative 2 is 3 times what?
Negative 2.
Negative 2 plus 5, yes?
Right.
Negative 6 plus 5, which is negative 1.
Right.
Does that make sense?
Right.
All right? A third. Same thing. 3, oh, you can't see that. You really can't. 3 times 1/3 plus 5.
Right.
We're pros at fractions now, yes?
No.
Good morning, everybody. It's time for the morning announcements. Please stand for the pledge of allegiance.
Uh-oh.
I pledge allegiance to Jackson Henry, also head to the
You gotta do this for homework?
Look at the F of F real quick. Everybody look up here real quick.
season opener last night.
Whatever is here is what we're replacing the X with.
In straight set.
3F plus 5.
That's it.
That's the answer?
That's it. Yep.
Congratulations to the Lady Bulldogs.
Thank y'all.
194-231 victory over Lugol Belgium. Members of this year's team are